What is up, folks? So what we're going to do today is taking a look at Advent of Code, day number 13. This was a fun one, so I figured I would go over it and create a video. Basically, what we have is we have a list of lists, right? Each row has a list. So we're going to go through and we're going to solve this Advent of Code problem, and we're going to be using Python. I'm going to use Python 3.10. So in this case, the goal here is to determine whether or not these two packets are in the correct order, right? So one of them should be coming before the other one. For example, this has 113, this has 115, so the ordering is correct. This one gets into a little bit more nuance where we have a 1 and a 1, so that's the same. But here we have a 4, but it's also an integer rather than the second item in this list, which is actually another list. The instructions tell us that we have to convert when you're comparing a list to an integer, you have to pretend like that number 4 is in fact inside of a list. So that's what we've got to do, is we basically say, okay, 4 inside of a list compared to 2, 3, 4. Now, 2, 3, and 4, so the 2 comes before the 4, so it is in fact in the correct order. Now we get into here, we take the first item in the list, that's a 9, and then the first item in this list is actually another nested list, so we would compare 9, in fact, here to 8, and so these are actually in the wrong order. So hopefully you get like the flow here. But basically the idea is, are these in the correct order? This one is in the correct order because you have fewer items, and so this one is in the incorrect order because you have more items, fewer items, and this one has fewer items, so it's in the incorrect order, etc. So you can sort of see how this flows. So we're going to write a script in Python. We're going to use the test data that they give us. This example right here, we're going to use this example data, and the expected output value here is 13. So let's jump in here, and I'm gonna pull up here. So we've got our input right now. This is hard coded in, but we've got an input.txt file, and we'll throw the input in there just to make sure that we get the right answer at the very end. I've broken this up into kind of five stages. So we've got to parse the data. We're going to build the logic to compare integers. We're going to build the logic to compare lists to one another. And then we sort of have to build logic for a flow. So we have to determine, are both of these integers, in which case we want to do a compare integer. Are they both lists? In which case we want to do compare lists, or is one of them an integer and one of them is a list, and then we need to put that integer into a list and then compare the lists, right? So we're going to use this compare as sort of like a flow manager. So it's going to determine which other function we run, and we're going to end up with a little bit of recursion here as well, because that's probably the best way to handle it is via recursion. Okay, so we've got part 1, also part 2. We obviously haven't looked at part 2 yet, and we have an expected output of 13. So in this case, we should have this output as 13, and we're just going to throw an assert in here, and we're going to assert that part 1, it does in fact equal the output. Okay, that's our expected output. So if we take our input and we take our output, we should get that. So let's start with parsing the data here. So we've got our data, and what should this actually look like? Now, I actually really like using the JSON library. So that's what I do here. Let's pull this down to down here, and we'll just sort of separate all of this out here. There we go. And then we can just focus here. So I'm going to import JSON. So the JSON library is going to be able to basically read this each of these lines of data. You could also use literal eval. I prefer JSON. I work with JSON data all the time. And I wanted to make sure that everything was a valid list that came in. So that's what I'm doing. I'm going to use the JSON library, so import JSON. And we're going to have all that data and everything, each of the 2 individual records that we need to compare are going to be separated by a blank line. So we're going to split along 2 blank lines, and then we're going to parse the 2, this line and then this line. So in this case, we've got data, and let's just do pairs is going to be data.split along 2 breaks here, 2 new lines, right? In this case, we're going to say for pair in pairs, right? And we're going to say, okay, here's, we want to split along the new line. So we've got pair, let's say P1, P2 is pair.split along the new line, right? And then we want to parse these using the JSON. So we'll just say P1 equals JSON.loads P1, and we'll do the same thing with P2. So now we should have a list, potentially a nested list. That's what that's going to look like. Okay, and then we want to have an output from this. And we'll have a list, and this will be essentially a list of tuples or tuples, depending on how you want to say it. So we're going to say output.append, and we're going to have P1, P2. Okay. So all we've really done is return the output. Okay. Is we basically parse the data that comes in, and then we're going to use this parsed data, and we're going to pass this to the compare function here. So in this case, we've got part 1. We're just going to say pairs. This is going to be parse data. That's the data. And then we're going to say for pair in pairs, we're going to compare. And in this case, this is actually going to be P1, P2, and we're going to compare P1 and P2 here. And we're going to add in some extra logic in here, because ultimately what we're looking for is the sum of their indexes. And we start counting at the index from 1. So we're going to get the sum of the indices. But first, let's just get back to whether or not we can do the comparison correctly. Okay, so the idea here is we want to have an output, and in this case, we're going to have an output that's actually an integer. We could say that we want it to be true or false, but the problem is that you if you just had a true or false, and you were comparing 2 integers, this, would you say that this is that 1 is less than 1? Well, you have less than, you have 3 different outcomes, right? You have less than, you have equals to, or you have greater than, right? And we want to be able to account for every single one of these eventualities, each of these 3 eventualities, so that we can know that we need to carry on to the next number to evaluate. So that's what we're going to do, is we're actually going to output whether or not the number is one of 3 different outcomes, and we're actually going to use 1, 0, or -1 to determine whether or not what that result should in fact be. So let's start with the integers, right? We're going to say we've got P1 and P2. That's the 2 pairs, and in this case, these are going to be integers. We intend to have integers come in here, and we're going to say if P1 is less than P2, then we're going to return a 1 here in this case. Actually, let's do a -1. We're going to do return a -1. And if P1 equals P2, we're going to return a 0. Otherwise, we're going to return a -1. Now, a 1. Now, in this case, what's important to note is, okay, we have the 3 eventualities covered. If I could say elif here, right? I could say else return 1. This would also work, but this is just slightly shorter. We know that if this is not the case and this is not the case, we're going to reach this line. So by default, this function is going to return 1. And this gives us our 3 different cases, right? P is less than P1 is less than P2, P1 equals P2, or P1 is greater than P2, which basically means that this is an incorrect ordering. Okay, so we've got our compare lists. This is the next one that we'll take a look at. This one, so basically what we have to do is we have to iterate through these 2 lists simultaneously, right? P1 is going to be a list and P2 is going to be a list, but we need to essentially iterate through each of them at the same time, and we're going to use zip to do this. So I'm going to say for S1, and this is going to be basically like sub list 1 and S2 sub list 2 in zip. And in this P1, P2. So basically, I want to iterate through both of these at the same time, S1, S2. So this is going to, basically for each item in P1 or P2, it's going to get, here's the first item in P1, first item in P2. And then when it iterates through again, it'll get the second item in P1 and the second item in P2, etc. So we can basically compare item by item simultaneously, which is really nice in this case because we want to determine whether or not this 3 is in fact less than the 5, right? That's what we're planning for here. Okay, so in this case, we want to say, okay, C is compare. So we're actually going to say we want to compare these 2 items, and this is because we might have nested lists, right? We might have a nested value here. So we want to say S1, S2, because if one of these is a list and the other one's an integer, compare will tell us what to do here for that, P1, P2, in this case. So see, we're going to compare. This is the result. Let's just say comparison, right? This is the comparison. And we're going to say if comparison is -1, then we're just going to return -1. If the comparison is 1, we're going to return 1. Now, in this case, we're not going to add an eventuality for 0 because if they have the same, if the result is the same in the terms of the number of integers, we have to check one more thing, which is the length of the actual lists. So we're going to do that. If length of P1 is less than length of P2, then we're going to return -1. Remember, this means that it is correct, whereas the 1 is incorrect ordering, right? This is based on the ordering. Okay, so this is the correct ordering, this is the incorrect ordering. If the length of P2 is less than the length of P1, then we'll return 1 here, okay? Now, theoretically, we should never have something that the problem is designed in such a way where we will never get a different result here. But you can always have return 0 here, or you could just say, I want to raise an exception. What happened? So we'll just say what happened here, because realistically, we should never actually reach this point in the flow. Okay, so finally, we've got our comparison here. And this is not necessarily going to be a list. This is not necessarily going to be an integer because we've got some recursion going on. It's like a step recursion, right? Where it's sort of like, it's like a cousin recursion. Compare is going to call this compare lists, and this compare lists function is going to call compare if we end up with when we do this comparison up here. So in this case, we've got a couple of different things that we need to check, right? We need to check whether or not both of the items are integers, and if they are, then we need to compare integers, and we need to return that result. We need to then also compare whether or not those both are lists, and then we need to compare whether one is a list or and the other is a number. So we've got like three different things that we're gonna check. So let's start with the easy one, which is, are they both integers? And we're going to say if is instance p1, and in this case this is an integer, and is instance p2 integer. Then we're going to say, then we're going to do return compare ints p1 p2, right? We want to return the result of these being both integers, right? And this is the result that we're anticipating getting. If is instance p1 list, and is instance p2 list, then we want to return compare lists, p1, p2, right? So we're comparing the lists. If they're both lists, we're going to compare the lists. If they're both integers, we're going to compare the integers. So we have two more checks here as well. If is instance, and in this case, I'm just going to do some copying here because it's very similar, where we want to compare whether p1 is a list and p2 is an integer, in which case we're going to return the compare lists for p1 and p2, right? So you see how I placed p2 inside of a list. So now I'm comparing two lists to each other. And then, of course, we need to do this same comparison where p1 is an integer and p2 is a list. And we'll do the same thing here where we compare the lists this way. Hopefully this flow makes sense. And then at the very end, we're going to raise an exception. What happened? But with a capital W so that we can tell where that issue was actually raised if we don't want to look at the full trace back. Okay, so now we've got our pairs. We're going to compare the data, and we should get back some kind of result. So in this case, what we're looking for specifically is where it's the sum of the indices, right? And we start the indexes counting at 1. So pair 1, pair 2, pair 3, and this should sum to 13 if we did it correctly for the example. So we have our pairs, we're going to compare those, but we also need to get the indices. So in this case, we're just going to do index, and we're going to do p1, p2 in enumerate pairs, and we're going to start at 1. We're going to start with 1. Okay, I don't need to include the keyword here, but I will just for clarity. Okay, so now we're going to compare p1 and p2, and we're going to sum the output. So output is going to be 0, and we're going to say if compare equals -1, that's the output that we're looking for, right? -1, if comparison equals -1, then we're going to say output plus equals index, right? We want to sum the indices of this, and we want to return the output. So theoretically, we should get back 13, which is the expected output here. So let's just run that really quickly. Assuming I can spell Python, run.py. We got an error. What happened? So there was, so in this case, we got an error here on compare lists. So it made it through, it checked each of these different pieces, compare, and we ended up with something along those lines. So let's just print out P1, and we're going to print P2. Oh. Okay, so this is a 1, this is a 1, they should be returning a 0, I guess, in this case. So if the length of one so in this case, we might need to say if length P1 equals length P2, then we return a 0 in this case. What's the line? What is the row of data that we have here? Oh, so that actually, we got a result. That's 13. So we did get the result back. So let's see here though, because we want to see what the comparison was. P1, P2. So it was this one and this one that it looks like it was comparing. One. Not sure where the error was happening, but we just fixed it. So in this case, we are getting 13 back correctly as expected. So that is correct. So let's try this with the full data that we have. So what I'm going to do here is I'm actually going to import sys. And in this case, we're going to use the data as the standard input, and we'll just copy the input from here, our puzzle input, into input.txt. Close that. And we're going to say that our data, our input here, is instead going to be sys.standard in, right? And our output, we don't want to actually check this output, right? That's our input. Okay. So in this case, we're going to cat the input, and we're gonna cat this to Python run.py. There we go. IO text wrapper, of course. There we go. Okay, so we want to read the standard input, what's being passed to the standard input. This is the number that comes back. Let's see if this is actually the correct number. Here we go. Bam, that is the correct answer. Okay, so now we're going to continue to part 2, and we're going to see what this continued. Now you just need to put all of the packets in the right order. So we actually have to put all the take all the packets and sort them. The distress signal protocol also requires you to include 2 additional divider packets. So we need to add this 2, and it's a nested 2 and a nested array of 6. So we need to add those into our data, essentially. Afterward, locate the driver packets. Okay, so we no longer care about the so we no longer care about the extra new lines, right? We're not analyzing these based on pairings. We're analyzing the entire thing as a whole. Interesting. Okay, so what we're going to do here is we're going to change this ever so slightly. So let's just have, let's just create a variable called flat data, and we're going to flatten out this data, but we'll initialize it with that extra 2 and that extra 6 because we need to add it to that anyways. So we'll have that 2 and that 6. And we're going to say for P1, P2 in parse data. For P1, P2 in parse data, we're going to flat data.append, and we'll append P1, and we'll append P2. Now we could also do just flat data plus equals P1, P2. That would also work. So yeah, we can do that too. Okay. And we need to then order the flat data and sort it. So what we're going to do here is we're going to import from the Python functools, from functools import a comparison to key. And this is going to allow us to sort the data. And we're going to be able to say flat data dot sort, and we're going to say the key is going to be comp to key, and this is going to be a lambda function. If you're not familiar with lambda, I will 1p2. Let me compare p1 and p2. Okay, so basically what we're saying is, okay, you're going to be sorting and you're going to be determining whether or not one of these items is less than or equal to this other item. And we want you to make that comparison based on the compare function. So compare to key, and in this case, this is the key here, which is the lambda function. All this does is it says for the P1, P2 that you receive, I want you to use the compare function to determine whether or not this is one value is greater than another. So we want it to sort in the correct order, and our function up above returns -1 if it is in the correct ordering, or 1 if it is in the incorrect ordering. So one of these will return 1 and one will return -1, and the one that returns -1 will be sorted first. There you go. Okay, and we need to, what are we trying to return here? The divider packets are 10th and 14th, so we need to multiply them together. And then you need to determine the indices of the two divider packets and multiply them together. So we've got the two divider packets, which is 6 and 2, and we need to find out what their indexes are and then multiply those indices together. Okay, so in this case, we have P1, we'll just stick with P1. P1 is flat data.index, and we know that we want the 2, and we have P2 is flat data.index of 6, right? And then we just return P1 times P2. Okay, so in theory, this will give us the result. Oh, there we go. So let's see if this is in fact correct. Actually, let's double check this. Well, I was going to double check this against the input. Let's double check this against the input, just to make sure that we're doing this correctly. Okay. There's our input. We'll just delete that if we get the correct answer. So this should be 117. Okay, so we did do it incorrectly here. So in this case, the correct result should be 140. This should be 140, and we should get the 10th and the 14th. And I think I know what exactly happened here. And that's because I did not account for the fact that they want to count from 0, right? So this is the index, and this should be the index plus 1, and this should be the index plus 1. So we basically had an off by 1 error, but we did it twice, right? So we're off by 2 error, I guess. So if we run this again, we should get 140. There we go. Okay, so let's remove this input again, and we'll run that. There we go. 27,690. So before we had 27,348, and basically every the two locations of the array for 2 and the array for 6, we were off by 1, and so we had a slightly different number. Okay, hopefully that is correct, and it is. There we go. Okay, so hopefully this helps. Hopefully this makes sense. If you have any questions, throw them below the video. Happy to help answer any questions down there as well. But happy programming. Hope this helped for admin of code day 13. I certainly enjoyed doing this one. It was kind of fun. There's been a lot of parsing of the inputs, so maybe I'll do some more videos on the different parsing that we've done before for those inputs, and some neat tips and tricks for handling how to parse those inputs. So there you go. That is everything.